We're talking today about the exposure time calculator, the ETC, specifically for JWST. So we'll start off with what is the exposure time calculator, and also importantly, what isn't it? So what is the ETC? It's a next generation exposure time calculator that's used for determining signal to noise ratio based on different parameters for the observations that you set up. So these different parameters include groups, integrations, dithers, readout patterns, subarrays. These are all knobs that you can turn in the ETC. It's a tool that makes use of instrument reference files. These are taken, from on-sky data. They've been validated against actual measurements. The results are guaranteed to be accurate to within 10%, and I think we are much better than the 10% level for most modes. And this is a tool that's also available to the public, both as a web application, which is what I'll be demonstrating today, as well as a Python scripting engine, which I'll describe shortly. What isn't the ETC? What is it not? It is not a complete observation simulator. This means that higher order effects such as field distortion or non-square pixels, full fields of view, things like that, they're not accounted for in the ETC. It is also not a source for observatory or instrument overheads or mode-specific limitations. So in this situation, when I talk about limitations, I mean for NearCam, for instance, NearCam in full frame readout mode only allows 10 groups per integration, but the ETC will not provide a warning if you exceed that 10 group limit. If you want information on overheads or limitations, things like that, you have to use the astronomer's proposal tool, and that is one of the other tools used to prepare proposals. The ETC is also not a source of pipeline-compatible data products. So while we do provide downloads for each calculation, they cannot be taken from the ETC and fed into the pipeline. That is not their intention. And the ETC is also not a tool with direct connectivity to APT. So while you need to take the information from the ETC and put it into APT to complete your proposal, there is no direct connection between the two. We've taken a lot of effort to make sure that nomenclature between the ETC and APT are consistent, but there's no push button to go from one to the other. You have to manually take those values over to APT. All right. If you're looking for additional information on some of the under the hood workings of the ETC, I'll point you to Pontoppidan et al. 2016. And there's an archive link here, and I'll also show that this link is available in the ETC itself. But if you're interested in some of the equations or the processes going on under the hood, I encourage you to take a look at this paper. Even though it was published 7 years ago, the fundamental workings have not changed since that time. All right, so I mentioned the Pangaea Python scripting engine. This is the code underlying the web application, and information can be found on the Pangaea engine news page, including installation instructions, reference files, everything you need to install it. It's available as a standalone tool that you can run on your local machine, whereas the web application requires an internet connection. There are some additional options available in Pangaea that aren't available in the web app, and this allows for some more detailed exploration and also like batch handling of calculations. We do have documentation specifically for Pangaea in JDocs. An installation is as simple as pip install. So check this out if you're interested in scripting the engine yourself. There's also a wrapper for Pandaea known as Pandexo. It's part of the Exoplanet Characterization Toolkit. This is useful for determining parameters for exoplanet time series observations in particular, and therefore only allows you to use a few specific modes in JWST, or a few specific JWST observing modes that are useful for time series. It's available as an online tool and as an engine, a scriptable engine that you can download, but with the caveat that this has not yet been updated for cycle 3, is my understanding at this point in time. JWST, the JWST interactive sensitivity tool, is kind of a slimmed down version of the ETC in a way. It gives a quick look of the signal noise you can expect for a given brightness and a given total time. And it's good for a first look at feasibility of observations, but ultimately you should be using the ETC itself or Pandaea to determine the specific observing parameters, like groups, integrations, things like that. That information is not included in JWST. It makes use of Pandaea results within a grid of brightness and time, but you're not able to turn all the knobs that you could, that you're able to do in the ETC. So this is a good first starting point if you want to determine feasibility, but then move over to the ETC to learn more. And finally, I'll mention APT, the Astronomer's Proposal Tool. ETC and APT are the two primary tools for proposal planning. APT is the final step when putting your proposal together and then clicking the submit button. So all the parameters you determine in the ETC get manually transferred to APT, and APT is also the ultimate authority on observation overheads. The science times reported in the ETC and APT will match, but the total time is only provided in APT, and that includes overheads. All right. So those are some of the other connections to the ETC, other proposal planning tools. Now, just show some information on how to get help with the ETC. So you're here right now to listen, to learn how to use the tool, but of course there are always going to be questions that come up along the way. The first place to look for answers is in JDocs. We have extensive documentation, over 50 pages, covering various aspects of the ETC, and these pages are all linked together. So it covers the web application, and there's also a section on how to use Pandaea. We also have context-sensitive help links sprinkled throughout the web application. They're little blue question marks. If you click on one, it'll take you to a page relevant to what it's next to, right? If there's a title that says subarray, and there's a question mark next to it, you can click on that and get information on, for instance, instrument subarrays. So in that way, we are directly connected to JDocs, and there are many other ways to access JDocs through the ETC. We also have video tutorials. These were made a few years ago. They're available on YouTube. There's 9 of them. So this was made in a previous version of the ETC. The basic workflow is still accurate. It's still valid. But the user interface will look different. We've made some changes over time to improve the look of the user interface, but as I said, they're still relevant in the sense that you can watch them and understand how to create a calculation or a scene or add a line, an emission line. So do check these out as well. There is a link to these on the main ETC homepage. If you can't find what you're looking for in the documentation or the videos, please do file a help desk ticket. I'm showing here the workflow. When you go to the help desk, you click on Get Help. It'll take you to a bunch of different help desks, and you click on ETC Support, and you can file your question there, and we'll respond to it within 2 business days.